Hello everyone. So we're going to start the next topic, that is the airfoil characteristics. So here we are discussing the airfoil characteristics topic. So in this aspect we are going to see the graph 1 and 2 here. So this is for the symmetrical airfoil and this is for the cambered airfoil. So as you are seeing that the airfoil, again we are saying here that the wing without tips is called as finite wing. So this is a finite wing and infinite wing are the two concepts we are seeing here. So the properties of a airfoil and the infinite wing are identical. So based on the unit length, whatever the span we are saying, so that will be the three-dimensional flow. So for the present discussion we are taking the two-dimensional flow, that is nothing but the airfoil. So typically the property of airfoil, the infinite wing are identical. So in this aspect we are going to see the graph here in detail by seeing the symmetrical as well as the cambered airfoil. So both are the airfoil which are used to generate the lift here. So here you can see that the y-axis is with respect to the CL here, and the x-axis with respect to the alpha. So here it is indicating that the 0 degree angle of attack. So here we can see that when angle of attack is keep on increasing from 0 to the certain level, say something like up to 10 or 15. So we can see over here that the lift, whatever the slope, whatever this slope is proportionally. So when you increase the angle of attack, lift coefficient is also increasing. So at that time you can relate over here in this situation that streamlines are attached. So streamlines you're going to get here, and these are attached to the airfoil. So the air flow is coming over here, and it is completely attaching, and the certain amount of lift is generating for this particular angle of attack. But in the same time, when you increase the angle of attack further, so by keeping in mind, without keeping in mind that the angle of attack to certain level, so if you cross for 15 or 20 or more than that, so at that time you can see that there is a suppression. So this is due to the basic ideology of the velocity profile, and you can see here that the separated region, so the reverse flow is occurring in this range, right? So the flow is diverted, so no more attached flow and no more streamlined flow. High turbulent reverse flow has been generated, so due to the viscous effect. So here you can see that the angle of attack, so here whatever we are saying with respect to certain slope, if we take a0, so this will be the angle of attack. So here you can see that, so the lift slope, what we can say here, so dcl by d alpha. So this is the effect of the lift slope here. So coming back to this is entirely effect of the symmetrical airfoil. Coming back to the cambered airfoil, so cambered airfoil is having the angle is so this is the symmetrical airfoil. So what we are seeing here, so the identical, so both you can see here that there is no upper as well as the lower surface are distributed properly. But here the cambered airfoil can connect this one, so upper as well as lower is not having a the area which are identical. So at this particular junction the negativity also is there with respect to this airfoil. So at that particular time, so at the 0 degree or negative of that, so minus 2 3 4 degree, so which indicates here that, so at that angle of attack also at the initial stages, so you can get some amount of a lift because of this the geometry. So at minus 2 degree angle of attack also you're going to get certain amount of a lift, but when you increase the angle of attack, so at 0 degree also you're going to get some amount of a lift here. So you can see that alpha L is equal to 0, that is nothing but 0 lift angle of attack. The value of alpha when the lift equals to 0 is called as 0 lift angle of attack. So here you can say that at 0 degree also you're going to get certain amount of CL. So same here, same concept has been taken care. So again if you reach some regions, say something like up to 20 or 21 degree angle of attack, so at that time you're going to get the stall effect, and there you're going to see that the suppression region, reverse flow will occur. So this this is very important aspect when you consider the airfoil. So airfoil performance especially. So usually it depends upon the different aircraft also. The military aircraft which are having the the maneuverability at very high level, so the stall angle will differ with respect to aircraft to aircraft. So this completes your the third unit. So we'll go for the next module.